This is my standard 7 reassessment, try 2, and in this problem we have a spring with a stiffness Ks, and its relaxed length is L. It stands vertically on a table, and we hold a mass M just barely touching the top of the spring. Question A says you very slowly let the mass down onto the spring a certain distance, and when you let go, the mass doesn't move. So how much did the spring compress, and how much work did you do? First, we are going to declare our system, which is the spring plus the ball. And we know that the force of the spring is equal to the spring stiffness times the amount that the spring has stretched or compressed, and that is Fs is equal to Ks. And because nothing else is touching the ball, we know the only forces acting upon it are the force of the spring and also the force of gravity due to its weight, which is mass times the acceleration due to gravity. And because the ball is not moving, we know that those two forces are equal in magnitude and opposite in direction. So we have Ks is equal to negative mg. And S being that it's the amount that the spring has compressed or stretched, that's what we're trying to find. So by dividing by K, we get S is equal to negative mg over K. And that's the amount that the spring compressed. How much work did we do on the system? We didn't do any work on the system because we are not touching it, and so we supplied no force to it. Question B is the same scenario as A, which is where very slowly let the mass down onto the spring a certain distance, and when you let it go, the mass doesn't move. But this one is asking what is the maximum compression of the spring. So again, our system is the spring plus the ball, and here we know that the weight is going to move down the amount that the spring compresses, and that's closer to the Earth's surface. So we know that there is going to be a potential energy change, which is equal to the change in the change in potential energy, and equal to the weight times the S, which is the compression of the spring. We know that the ball is not moving, and so there is no kinetic energy here, but there is a potential energy due to the spring, and we know that potential energy is equal to 1/2 times K times S squared. Since there are no other energies here, we know by the conservation of energy that the potential energy at displacement S, it must be equal to the change in the gravitational potential energy, which is mgs. And so then we have mgs is equal to 1/2 K times S squared. And again, we're trying to solve for S, so that would be equal to 2 mg over Ks, which is where the m is the mass and the g is the acceleration due to gravity, over K, which is the spring stiffness. And that will give us the maximum compression of the spring.